Now we will discuss about the factors on which force depends. Though we have already used the formula F equals to ma, we can derive this formula from this topic. Okay. First thing, suppose there is a surface on which there lies a block. Okay. Now we use a force F to move this block from this position to this position, right? From A point to B point. Okay. Now again think of another block. This is the surface and this another block. This is A position, this is B position. Okay. And this is the surface. We are applying the same force F. What will happen? In this case, the box will move very easily. But in this case, the box will not move so easily and we have to increase the amount of force. We have to increase the amount of force to move this box to this B point. Okay. Thus, we can say that force depends on mass of a body. What does this sign mean? This is the sign of variation. You will learn later in mathematics. This is a sign of variation. This means that, see, this is an example. If we say A varies B, A varies B. In proportion chapter in mathematics, we will learn this. Okay. A varies B. This means when A and B are two different things. Okay. If B increases, A will increase. If B decreases, A will also decrease. This is the relation. A varies B. That means when B increases, A also increased. When B decreases, A also decreases. Okay. This is the relation. So the first factor on which force depends is mass. Mass of an object. Okay. If mass increases, here see, the mass of the block is increased. This is a bigger block, so more force is required. Here it is a smaller block, so less force is required. Okay. Okay. Let's just note down a small thing. Though I have told you earlier, acceleration. What is acceleration? Acceleration means rate of change of velocity. Okay. That means, suppose let it be a bike, okay, or cycle. A cycle was going with a velocity of 5 km per hour. Okay. You have increased this velocity to 7 km per hour within this time t equals to say 5 minutes. Okay. That means you have accelerated. In bike we do not. We have the accelerator in our right hand. We just accelerate the speed. That means we are increasing the velocity with respect to time. This is known as acceleration. And how do we mathematically represent this? A equals to v minus u by t. What is v? Final velocity, that means 7 km per hour. What is u? Initial velocity, that means 5 km per hour. And what is t? How much time is required to accelerate or to increase that velocity? Acceleration means increasing velocity, okay, or increasing. Okay, so this is acceleration. Now see, for the same diagram, okay, this is one block and this is another block. We are applying the same force F. What will happen? For smaller block, what will happen? Acceleration is more, it will move faster, right? And for bigger block, it will move slower. Okay, that means acceleration. If now see, okay, sorry, take another example. Take another example. For same block, okay, same block. same size block. F1 is applied and here F2 is applied. Okay, now say F2 is greater than F1. What will happen? This will move with an acceleration of A1 and this will move with an acceleration of A2. And you will find this one will move, since F1 is less, these two are same block, right? Since F1 is less, it will move slower and it will move faster. That means it's getting more acceleration and it's getting less acceleration. Thus, the second relation comes, F varies as A. That means when force is increased, when the object is same, obviously, okay, for same block, for same object, when force is increased, acceleration also increases, and when force is decreased, acceleration also decreases. Okay, these are the two relations, and from these two relations we will form the formula F equals to ma. Let us see how. Okay, there is another one rule in proportion chapter you will learn later. A varies as B, this is one relation, and this second relation, A varies as C. Combining these two, we can write A varies as BC. Okay, these two will just get multiplied. We can write A varies as B and A varies as C. Combining these two, we can write A varies as BC. Okay. Similarly, here what we can do, combining these two, we can write A varies as MA. That means A multiplied by A. Now again there is another rule. When we change the sign from proportion, vary sign from equals to, there comes a proportional constant. A equals to, when we write equals to instead of this proportionate sign, there comes a constant. Some constant. Constant into BC. Okay. There occurs some constant. So what will happen in case of this equation, if varies as MA? F equals to KMA. This is the proportionality constant. Proportionality constant. Okay. Then you will say, sir, you have written F equals to MA. Now you are writing F equals to KMA. What does this K gun? See what happens. Right? Now think, unit force is applied to unit mass producing unit acceleration. That means 1. Force is unit means 1. 1 unit of force is applied on an object of unit mass. Unit mass means 1. SI, CGS we don't need to bother about. Okay. Unit force is applied to a unit mass to produce an unit acceleration. Okay, that means F equals to 1, M equals to 1, A equals to 1. What will be the value of K? What will be the value of K? K is equals to what? F by MA, right? From this equation, K is equals to F by MA. K is equals to F by MA. Okay. So 1 by 1 into 1, that means K is equals to 1. So 1 multiplied by anything, what remains? 1 into A, that means A, right? So we can write F equals to MA instead of writing F equals to KMA. Okay. You can just write like this: for unit force creating unit acceleration on a body of unit mass, the value of K is equals to 1. Therefore, F equals to ma. Thus this formula comes. Okay. Now we will just come across one very important question and very common question also. Okay. I will say it's a very common question for your board's examination. What do you mean by 1 Newton force? What do you mean by 1 Newton force? See, what I have said, what is Newton? Kg meter per second square. That means 1 kg, 1 meter, 1 second square. This is 1 Newton, right? So you have to write like this: the force which produces an acceleration of 1 meter per second square on a body of mass 1 kg is known as 1 Newton force. Okay? So let's just write the answer. The force which produces an acceleration of 1 meter per second square on a body, on an object of mass 1 kg is known as 1 Newton force. Okay, so if anyone asks you what is 1 dyne force, you can easily say just replace CGS in place of this SI units. Okay, you can say the force which produces an acceleration of 1 centimeter per second square on an object of mass 1 gram is known as 1 dyne force. Simple. Okay. Now for a comparative study, I can say this touch, the simple touch, it is more or less 1 Newton force. And just keep your hand here near your mouth. The breath, the amount of air that falls on your hand, the force which is created by that air is more or less about 1 dyne force. This is a comparative study. It's not a very accurate measurement. Okay. Now we will see the relation between 1 Newton and 1 dyne. Relation between Newton and dyne. Whatever. See, 1 Newton means 1 kg into 1 meter per second square. Right? So we have to find in dyne, that means we have to convert this CGS into SI. We have to convert this SI into CGS. Right? 1 kg means how many gram? 1000 gram. 1000 gram into 1 meter per second square. How many centimeter per second square? Meter to centimeter multiplied by 100. That means 100 centimeter per second square. Okay. Now just take this in one side. See, we have already got this term, gram centimeter per second square, that is equals to dyne. Okay, that means how much? 1 lakh dyne. That is, we can write 10 to the power 5 dyne, or 1 lakh dyne, you can simply say. Okay, this is the relation between Newton and dyne. Sometimes this also comes in your examination. Okay. So just write it.